one kind of makes sense if you see it in the long way, but it's much, much easier to look at them with factors because you can visualize where it's going. Your x squared, you know it's an x squared. You can see where your roots are. You know they open up. You can kind of visualize a little better. X cubed, this gives you an x cubed, and the other one gives you an x to the 4th power. You guys okay with this? All right. So here's another challenge. Here are your roots, your zeros. Guys. All right. Find me the equation. Okay, let's say you got x minus 3, x plus 5,
x squared minus 4x
plus 1. Everybody get that? And we have to say equals. It's got to be an equation. It's got to be a function. It's got to be equal to something. So we got. Looks good. Yes. This came from these two. They're irrational roots. What happens is underneath when you do the quadratic, underneath the square root, when you describe the nature of your roots, they're irrational. It's an irrational number. So we have two things. Sum of the roots, product of the roots. Two equations. This is going to give us A, B, C. This is this part. Now, easiest way to do this is to take these two like this, put a plus sign in between them, put them in your calculator. When you add them, your radicals cancel out. So your sum is 4. We're going to let A be 1. Therefore, negative B is equal to 4, and negative 4 is equal to B. Okay. Product, do second enter, pull this down, and change the plus to a multiply. Multiply are your perfect squares. 4 minus 3, and it's 1. We let A equal 1, and then C is 1. And then you can plug these pieces into that, into the, excuse me, into your quadratic formula. Okay? Now, remember, if I give you one of the conjugates, you know that there's a second conjugate with the opposite side. So say I just gave you this, you would still know that there's got to be one more root. This has to have a matching pair. It has to have this root with it. Good? Questions on this? This is not the bad part, right? It's kind of good. Whenever you struggle, start with the basic. Just make any quadratic. Start this way, work it forward, and then watch yourself work it backwards. It's an easy way to do it. Okay, now what I want to do is I want to go over the equations that the functions that you handed in. You have to make sure you understand this. Most of you are getting it, but a lot of you are missing this, and this is really, really important. Some of you gave me no decimals, and you copied from each other with no decimals. Okay, start like this. Your highest one is a 4. So how many zeros should I have? 4 zeros. Describe my end behavior. Both up. Leading coefficient is positive. Both ends up. They behave the same. That's your leading coefficient test. 4 zeros. 4 minus 1. 3 terms. 3 minus 1. 2 inflection points. You've got to get 2 inflection points out of this. Inflection points, remember, are where they're concaving one way, then they kind of change and concave the other way, and then in this case it'll happen again. So this is the way we start. So then I had you find all the exact intercepts. These are your zeros. So you set this equal to 0. When y is 0, we find your x-intercept. You have to factor. So what can you factor out of there? X squared. Can we factor again? Trinomial x plus 4, x minus 3. These are all set to 0. Here's your double root. Most of you are getting this part. Most of you are getting find me the roots. You also needed to find me the y value. The x where crosses the y-axis. When you plug all your x in for 0, let x equal 0 and find your y. I didn't take off if you didn't do this. But you should. This is finding your intercepts. And of course we know it would be 0. When you do this on your calculator, you see this point 0, 0 right here? You were able to sketch this, and you were able to tell me, here's a 0 root, here's a 0, here's a positive 3, here's a negative 4. You were able to do the 0, but yet, if you find it on your calculator, some of you are getting that thing with the negative, with the e to the negative something, because your calculator behaves differently. And it gives you like 2.49 something e to the negative 11. That means move your decimal point 11 positions to the left. That is 0. Both of these had a 0, 0 intercept. And on each one, someone, at least a couple of kids gave me 2 point something or other, because it's saying e to the negative 8, e to the negative 11. That's a scientific notation number. But you know it has to be 0, 0. Now, you know your end behaviors are going to go up. It has to bounce off of this. These have to come through. Just a good way to sketch. And my board's off, of course. Now, because this is wider, this probably was the longer one. Bounces off and comes up. Once you put it in your calc, you kind of get a better idea, but most of you are getting the graph of this one. The graph of the other one I thought was easier, but some of you missed the graph part. So start like this. Then we had to find your intercepts. This is an absolute minimum. This guy, we'll label him A. B is a relative minimum. And I want to see you call them relatives and absolutes. Absolutely the lowest one there. This guy, C, is a relative max. Well, we know C is at the 0, 0 because we put it there. In your absolute minimum, most of you were able to find your absolute and your relative minimums. Relative min, I'm not sure if this one's right. That's 211. And I went 3 decimals. Now, once you find this lowest point, you can define your range and your domain. Your domain was all real numbers. I can use any x, and you should see that when you put it in your y equals. My range, that's the lowest, absolutely the minimum point. That's a hard bracket. Negative 54.674 to infinity, soft bracket. Get your brackets down pat too, because a lot of you are off in your brackets. Okay? Increasing, decreasing. We've worked on increasing, decreasing for a long time. Increasing. This is the value of y increasing, but you read your x values. Increasing, decreasing, value of y decreasing, but you read your x. So it's like a roller coaster. It starts from up here. Is the value of y increasing or decreasing? Decreasing. From x it's what? To this x value, whatever this x value is. This is decreasing from negative infinity to negative 2.853. That's one part. Just work one part at a time. Then what are you doing? Increasing from that little section to 0. Then from 0 to b, we're decreasing. We're decreasing. And then the last part, from b on up, we're increasing. You're increasing, decreasing, get soft brackets, not hard brackets. Soft because they have to share those numbers. Where one ends, the other one picks up. So we give those a soft bracket. Any questions to now? A lot of you had trouble with the increasing, decreasing. Some of you are still giving me the y values. It's the y decreasing or increasing as x goes from left to right, as x goes from 0, from a negative infinity to positive infinity. Okay. The inflection point. An inflection point has to do with your concavity. Look for your caves. Here's a cave up. Here's a cave up. And in the middle of all this is a cave down. So look where they share. So when you want to share something, you want half of it. Find the halfway point. We'll call this D and E. Halfway means you take this x value plus this x value and divide by 2. So your value of A is negative 2.853. Your value at C is 0. And divide it in half. This will give you your x value. So your x value would be negative 1.427. This is an inflection point. Now, go to your graph in your calculator to second calc. Put in that value of x. And you get back your value of y. Let the calculator find you this. Okay? That's one inflection point. That's D. And we're going to do the same thing to find E. We're going to take half of this guy. So from 0 and 2.103 divided by 2. So E is going to be at 1.052. Put it in your calc and find your inflection point. An inflection point has to have an x and y. Do we ever need the y again? No. But an inflection point has to be named as a point. And so far, all you guys should make your changes because this is what you need to study from tonight. Because you'll have two that look exactly the same as these tomorrow. Exactly. Not the same numbers, obviously, but it'll be the same setup. You know, it'll be the same, like 1 is an x and the fourth one is an x cubed. Now, your concavity. Last thing we do is concavity. It's the same as your increasing, decreasing, only now you're just following the caves. We're concaving up from negative infinity. There's a concave up and a concave down. We're concaving up from negative infinity till we hit that x value of that inflection point. So from negative infinity to negative 1.427. Then we're concaving down between those two inflection points. That's the easy. I think that's the easy one. Because you're right between your two inflection points. And then from there, you're concaving up to infinity. Again, those need soft brackets as well. Because they're sharing their points. When I graded this guy, okay. Alright, first of all, how many zeros are we going to have? 3 zeros. What are my ends going to behave like? One down, one up. Since it's positive, down on the left, up on the right. How many turns am I going to have? 2. How many inflection points? 1. 1 inflection point. So start with your zeros. Set this equal to 0. What intercept am I doing when I set the y to 0? The x. These are the zeros, the real zeros. This is the algebraic solution. Yeah, you can put it in your calculator. Yeah, you can put them on your graph, but you got to do them algebraically. What can we factor out? X. Not a square, just an X. Okay? X minus 5, X plus 1. Most of you are able to do this. Usually with the factors, they're not that bad by the time you factor out. Because the goal is not to test your factoring. The goal is to test where your graphs are going and the zeros and everything else. So usually the factors are not that bad. So again, you have 3 roots. Do you have any double roots here? No doubles. So each one's going through the axis. Now, when you start this, put them down here. 0, 0. That is the point 0, 0. Okay. So regardless if your calculator says 2.89 something e to the negative 11, it is still a 0. X is 5 and X is negative 1. Down on the left, up on the right. These guys, oops, you know what, I'm gonna do it over here. It's just much better over here. I think my board is just warped. These guys have to go through. They're not doubles. So they have to come through here. This one also has to come through. So the only way to hook this up, as you see it, is to come up, come through, and down. It's going to come like this. Some of you missed this little hump over here. And when you put it in your calculator, it was small. If it's too small, zoom in on your window. Just make your window right in here, negative 5 to positive 5. And you'll see it a little bit better. But by sketching it yourself, you should have seen this is a little hump right in here. So now we have your zeros. So let's find your relative mins and max. This guy and this one. We'll call this A, B. What's this one? Oh, I already labeled it. Is this called an absolute or a minimum? Or an absolute or a relative? Relative. Max. How about this one? Relative min. And I want to see you call them the right things. 3 decimal places. Your relative max was at negative 0.523. And you know it has to be less than negative 1 because that's where your 0 is. 1.378 this is. Okay, and B, it has to be somewhere between 0 and 5, and make sure it makes sense to you. You would have to change your window. Is everybody comfortable changing the windows in their calcs? If you need to see where it turns and it's low, it's going under the Y-min, just hype up that Y-min to negative 100 if you need to. 3.189. Sorry. Guys, have a seat, and let's finish this. Domain and range, all real numbers. Both of them, all real numbers. Let's do your increasing. Increasing is going from here. We're increasing till we hit that x point. Negative infinity to that x point. Then we're going to decrease from that point to that point. And then we're back on an increase from there to infinity. Once you do your increasing, decreasing, you should see your entire domain here. You covered all your domains from negative infinity to this point, then from this point to this point, then from that point to infinity. It should cover your whole domain. You have one inflection point. It's the point between here and here. Now, it was not at the 0, 0 because this is much, much lower down. So you're going to add up your x values. These are your 2 x values. You're going to add these up, divide by 2. That's going to give you your inflection point. 1.333, and you're going to find it in your calc. And now, you can do your concavities. You're concaving down from negative infinity to 1.333. Guys, another minute.
Good morning,
Then
University
you're
Academy.
concaving up.
Please excuse this interruption. We just wanted to wish the NFA varsity goalbacks on their win against STEM on Saturday. They won the semifinals, and now they